Hello everyone, so in this video let us talk about the problem from latest LeetCode weekly contest C92. The problem name is lexicographically smallest string after operations with constraint. So let's read the prompt statement really carefully because I actually also get confused at a little point. But let's say the prompt statement. It says that you are given a string s and an integer k that is given you as an input. You have to define a function. There's a function that defines the distance between two strings s1 and s2. So the distance between two strings s1 and s2 of the same length is defined as the sum of the minimum distances between each ith character in both the strings. So S1 and S2 are the two strings. The ith character, the sum of the minimum distances between each character in the strings, the sum of them the sum of them is called, you can say, is defined by this distance function. Also, when the character from A to Z are placed in a cyclic order, which means that all the characters are placed in a cyclic order. So, which means that you can find out a distance. So let's say it is A, the characters are, let's say, A, B, C, D, and so on till like X, Y, Z, and then after that it again comes back to A. So which means that in the cycle manner, all these characters are placed, and a distance between them, let's say A and B, is distance between them is 1. X and Y, it's 1, but Z and A is also 1. Okay, that's the overall thing that you have to understand. That now what you can do is that this is a distance. So let's say the distance between A and B is 1. Okay, and A and Z is also equal to 1. It's a cyclic manner. Now what you can do is that can you can change any letter of S to any other lowercase letter, that you can change it any number of times, but you just have to do that such that you have to find out the lexicographically smallest string. You have to find out the smallest string, lexicographically smallest string, such that the distance between S and T, the new string that you will form, you have to find out the new string T, that is the lexicographically smallest string that is formed such that the distance between S and T has to be less than equal to K, that is K that is given here. Now the problem statement seems a little bit difficult to you, but the actual thing is that any, like, if you see some examples and anything, like if you got stuck in like what's the overall thing, how you will proceed it, you can understand that you are given in string. Take a look at some example, understand what they are trying to do. So what you can say is that even if I have some string, let's say that is Z, B, B, Z, I have to find out lexicographically smallest. You have to understand what is the lexicographically smallest string. Lexicographically smallest means that let's say if you place all these strings in a dictionary. Okay, a dictionary has some order. Let's say we have first C, A, then O, then B and C. But if you have AA, so AA will come first, then like B, BA, and then CA. So it has some order. So that is called a lexicographically smallest order. You have to place and find out the string that is the lexicographically smallest string, which is closest and has a distance of S and T less than equal to K. Okay. So as you can see here, what they have done is that to make it lexicographically smallest, they have tried to convert these characters to A. As you can see here, that the as close these characters comes to A, then it is lexicographically smallest because it will come in the top of the dictionary. Okay, so that is why they actually wants to make it as close to A, because less than A it doesn't matter. So which means that our also objective is to bring as much characters more close to A. Now to get close to A, there are two ways. Okay, let's say I have the cyclic, let's say you can say pattern. Let's say A, B, C, D, so on, then X, Y, Z, and then again back to A. Okay, so let's say I have any character D. Okay, now if I have a character D, now the distance from A to D is, let's say, distance. This is the distance. So, okay, now if you have seen a circle, let's say you have a circle. Let's say this is A. Okay, and this is some character. Let's say any character. Let's say alpha, or not alpha. Let's say any character. Let's say X. Any character. Now distance between A and X can be done here. Like you can go in the clockwise manner or an anti-clockwise manner. There are two ways to go to A. Okay, let's say from any character. Let's say you are at any character. Let's say S. So S, you can go back to A, or you can go from S to Z and like do like a cyclic convert, like cyclic bound, and then go to A again. Okay, so there are two ways. So you have to find out the distance between S and A in both of these manners and find out which is the smaller one, because that is the small, because I have to choose the smaller one so that I can get more characters to A in a less number of distances. I can then keep on adding the characters, how many like you can say distances I have covered to get to A, and I have to keep it inbound to K. I have to keep it inbound to K. Now, the next thing is that if, let's say, I have somehow used all my utilities of K, and let's say some small K's left. Let's say only two K's left. Like I have only two chances to do. Okay, now I don't have any much distance. So let's say if even if I go from here to like from any x to a or from x in a cyclic manner or a cyclic manner, both of them doesn't reach to a. Okay, like both of them doesn't reach to it. Then what I will do? I have to use some k. What I'm trying to say is, let's say the characters are uh, s. Okay, let's delete them out. I close the. Let's say s Vx and I want to k equal to 2. So I want to make my first s as close as possible to a. Okay. So now if I go in the cyclic manner, let's say I want to move it towards z and then I want to go to a. That is also not possible because I have only k equal to 2. If I make it x s t u, so it will max to max become u, and I can go back the q p p q. Yes. So it will become P. It can go back till P, maximum P, and it can go back to U. So if you have seen that it can either convert to UVX or PVX. Which one is smaller in the dictionary? Obviously this one. So which means that if I have a K which is not sufficient to make this character go to A, then I will make it back to the one that is the smaller one. Like I will only make it go back. Okay, let's say so that it will come like it. This character will come greater, like a lexicographically smallest one in the dictionary. I should not go in the cyclic manner from Z and to A because I will not go to Z and comes back to A. It's better to go back and get a character that is much smaller, and I will somehow utilize my k and utilize my k, go two step backs, get this character which I can get because k equal to 2, so I will get maximum this string, and this string is lexicographically smallest one. Okay, that's the complete logic that you have to use. We moved on to the code part now. You can also pause it and try to write on the code part by yourself as well. But let's move on to the code part now. What we have done. So this is the count. This C variable is the count of how many you can say how many operations we have done till now. Okay, so what we have done is that this stores how many operations because I can do at most key operations. So I have to somehow store how many operations I have done to move one character to A, another character to A, and so on. So that is this number of operations we have done. Now we'll do a for loop over all the strings. Now we have or like you can say options. I can go in the clockwise manner or anti-clockwise manner. So let's say the distance from B to A, I can directly just subtract out. If I subtract S of I because this is D which is larger, so if this SKI characters, this is so let's say this is 26. Let's say these are the SKI characters. So let's say the SKI character of A is someone, and let's say it is equal to X. So this is X. So this is X. The B will be X plus 1. The next one is X plus 2. D will be X plus 3. So if I want to find a distance between D and A, I will just subtract out their values in the ASCII manner, like the actual characters, and it will return it in the integer format, whatever is the distance between them. That is perfectly fine. Okay. And if I want to find it out in the clockwise manner, then I have to subtract out from A to D, like A, S of I, like this is S of I, which is always greater than A. So this will return a positive number. But if I do A minus S of I, it will return 0 or a negative number. For that, I will add 26 and mod it to 26 so that I will get the other way around. What is the distance? This are the two distances. Now I have to find out the minimum of them. As you can see, if the minimum of both of them is less than k, these are the two operations that will lead my character to go to A because I want to go to A. If any one of them character is less than, you can say if any of the distances which I have covered is less than k, which means that I still have some bandwidth. I can use the minimum of them and reach to k, or let's say I will reach to A. So what I'll do is that I will subtract out the minimum of both of them and I make my S of I equal to A so that I will reach A. But if the k is not sufficient to get it to A, which means that I have to go back only. So S of I minus k, so that whatever characters I have to go back k times so that I will get back to that particular character. Now k becomes 0. I will break out of this for loop and then return S. I have to also use k here in this end condition so that I should not go inside the for loop if there is no k available for me. So this is the condition I check, that if S of I is less than the size, and also I have some k so that I will use some k to do some operation. If it doesn't have any k, what's the matter to go inside this whole thing, because I will only do operation if I have some k. in the end I have S that will have the lexicography smallest string that we have done after all this operation. I hope you understand. You can rewatch this video. If you still have doubts, you comment in the comment box of this video. I have done all of this in O of n. As you can see, this is just a simple for loop that we have used here. Nothing much complicated here itself. This is just you can say logically different heavy problem. But if you like rewatch it, if you have any doubts, you comment in the comment box. I will be happy to help you out. Thank you for watching this video till the end. I will see you in the next one. Keep coding and bye.